Hello, everyone, and welcome to this webinar today. Thank you for taking the time to join us. This is from idle to efficient, boosting lab equipment utilization in R&D. I'm Will Patrick. I'm the head of marketing here at Calira, and you don't see my photo on the front page here because I'll be hosting today and keeping us moving along. But I am joined by Johannes Solsbach, CEO and co-founder here at Calira, and Dr. Craig Davison, Senior Account Executive here at Calira also. And just to set expectations up front, this is not for a demo. We won't be looking at anything like that today. The goal today is really to give you practical ways to think about equipment utilization, including why it's often misunderstood, what typically drives low utilization in labs, and what actually improves it in the real world. But most importantly of all, why it's not that simple to talk about as a concept, particularly in R&D. There's a lot of nuance here, and it's not just an exercise in making the number go up. Um, the format for today is that Johannes is going to kick us off with the big picture, and then Craig will be taking us through a structured approach to diagnosing and improving utilization. So this is our agenda for today. We're going to start off, of course, with the importance of utilization, which I think should be no surprise to anyone on the call. We'll be looking at immediately at a real world example of that, and then moving very quickly into a structured approach to looking at, thinking about, and improving utilization. We'll also be looking very closely at how we actually define the problem. Is it really a problem? How do we think about it? How do we look at it? We'll then also move on to the gathering and analysis of utilization data, how to do it, where to get that from, and what it should all mean. And only then we'll be looking at what are the common problems that we see with our customers that we start working with, and the data that we have about lab equipment, and some of the perhaps surprising solutions to some of those problems. And you'll want to stick around for that one. We'll also be able to look at some real world data from Calira customers towards the end as well, right before we get into the Q&A and closing things out. So if you have a question, feel free to put that into the relevant chat window. I'll be able to gather those as we go, and we'll ask those at the end. So without further ado, I'll hand over now to Johannes, who will be able to take us on to the next slide.
Thanks very much, Will, and hello everyone. As mentioned, my name is Johannes. I'm one of the co-founders at Calira, and when we speak to lab operations teams, one statistic that really surprises people is how much expensive lab equipment is actually idle. And you will often see figures like 35% is in use, 65% is unused. The exact number will certainly vary by lab, instrument, but also environment. And that's not really the point here. The important thing is that issues around utilization are not only extremely common, but utilization itself is often invisible. And the quote here on this slide captures this well. In many labs, utilization is tracked in a shared spreadsheet or in a calendar, but no one is actually analyzing those bookings at the end of the year. So when questions come up about capacity, budgets, or new purchases, people are relying on gut feel rather than evidence. And if you can't measure utilization in a clean way, it's very hard to improve it, obviously. And it's even hard to defend decisions to leadership. But I know the thought that is running through many of your heads, maybe, well, Johannes, utilization isn't that simple. There isn't one single number that works for all labs, for all pieces of equipment, for all scenarios, and you might as well be right. Truth be told, utilization is far more nuanced and is a far more nuanced issue, like Will said, than just a single simple number. And that's something that Craig will be getting into in detail in a bit. But before he does get into that, I want to mention that low utilization is tricky because it's often both a cause and a symptom. As a cause, it creates very real problems. Research slows down, bottlenecks appear, expensive assets don't deliver the value that they were bought for. And as a symptom, low utilization usually points to deeper issues in how the lab operates. Things like, for example, poor visibility into when and where equipment is available, its status, unclear ownership, awkward workflows, or hidden constraints around training, data, or maintenance. And you tend to see the impact in three areas. Firstly, research wise, work takes longer and dependencies just pile up. Secondly, financially, you'll see wasted capital and pressure to buy more equipment than you may actually need. And thirdly, culturally, sorry, the frustration builds. Scientists may feel blocked, lab ops could feel reactive, really, and everything probably feels harder than it actually should. Again, the key point is that these problems are solvable if approached in the right way. Now, this data, what you can see here, is from real customer environments across shared labs, growing biotech companies, and large enterprise organizations. What it shows is that utilization can improve over time, regardless of scale. This is not a one-off transformation project or rewriting every SOP. It's about having a structured approach, making problems visible and fixing the right things in the right order. But before we go any further, though, it's worth checking where everyone's starting from. I will hand over to Craig now to kick that off. Thank you.
Thank you, Johannes. Hi everyone. It's great to be here today, and as Johannes said, it would be a great way to kick off today's session by asking a question for the group. So that question is, how confident are you that your lab's equipment utilization is as high as it reasonably could be? There's no right or wrong answer here. We're just trying to get a feel for the room. We'll give you a few seconds to answer that question, and then we'll walk through a real world example and, really kick off today's presentation. In the meantime, I can kind of introduce myself. Obviously, I'm Craig. I work at Calira. I have 7 years experience working in R&D in a laboratory as a molecular biologist, both in academic and industry settings. And 4 years ago, I transitioned into the software side of science and speak with lab ops leaders every week. And that's why I'm here to talk to you today about equipment utilization. Once we have some answers in, we'll take a quick look at the results. And yeah, okay, not a huge surprise there, that a lot of people on the call aren't very confident and think that they could do better, or there's a little bit of a mix, but very few people are really confident that their utilization rates are great across the board. So you're in the right place to kind of learn about ways that you might be able to track this problem and improve it. So as I said, I speak with scientists, lab ops teams, and site leads every week. So to start this webinar off, I wanted to look at a real world example. This lab was convinced they had an HPLC capacity issue. Scientists felt frustrated, projects were delayed. Every conversation seemed to suggest we need to purchase a new system. But budgets were tight, so they investigated further. And luckily they did, because when they tried to quantify actual usage, the data said something very different. In reality, the HPLCs were only in use about half the time. When we looked closer, the story wasn't about the instrument at all. Why? People were booking very long periods, sometimes multiple days, but when looking at actual usage data, typically they would use the machine heavily on day one, and then a little on day two, and most of the time not at all on day three. Why? They were adding 24 hours more than they needed, just in case. Why? They were trying to protect themselves from uncertainty. They didn't know whether they'd need the rerun until results were analyzed. Why? The analysis was happening on the computer next to the instrument, so the instrument stayed occupied longer than it needed to. Why? There was no shared data server and no dedicated space to store samples between runs. This is clearly a cultural and procedural problem, not a lack of HPLCs. So from the scientist's point of view, the HPLCs were always unavailable and were a bottleneck. And this actually only made their bad habits and the overbooking worse. The solution here wasn't to buy more equipment. It was fixing the workflows around booking behavior, data access, and sample handling. This example is important because it shows something that we'll come back to again and again today. Utilization problems are usually system problems, not asset problems. First, I want to talk about a system for improving equipment utilization. If you've had exposure to Lean or Six Sigma, the way we just walked through that previous example probably felt familiar. This isn't going to be a formal training session. I want to keep this short and practical, but it's a good way to think about this challenge. And that's because most utilization discussions actually fail because teams jump straight to solutions. So someone says we need more equipment, someone else says we need stricter rules, but there's no silver bullet. So we need to approach the work in a structured way to ensure that you reach the right solutions for your specific challenges. One way to do that is to use DMAIC. This forces a kind of structured order to kind of identifying the problems and solving them. First, you define what problem you're actually solving. Then you measure what's really happening, analyze why it's happening, improve the system, and then control it so you don't drift back. It's not complicated, it's just a structured way of thinking and is the core framework of Lean Six Sigma. So this step sounds obvious, but it's actually where most teams go wrong. When someone says we need better utilization, they often mean very different things. So some instruments are supposed to have low utilization. Maybe they're highly specialized tools or equipment used for rare assays. These shouldn't be run constantly. So maybe something like a 20% utilization rate in that example isn't a failure. On the flip side, some instruments are almost always in use. Maybe that part of the lab is almost fully automated. Maybe the instrument can, in theory, run 24/7 and is mostly hands off, obviously disregarding some time for maintenance. In that case, maybe an 80% utilization rate is actually a failure and is not as high as it could be. From our experience at Calira, especially in R&D, there's this very large middle ground with lots of opportunity for improvement. So equipment types that feel oversubscribed at certain times or in certain labs, but sit idle in others that are maybe, just across the road or up a floor. Maybe you've already spoken to various people and looked at this from different angles. Maybe you've heard one scientist say, this seems fine to me, another say we need more equipment. Leadership says we need reports. The point is that improving utilization might mean very different things to you on this call than it does to me. There's no standardized way. What I will say is that our data and independent reports in R&D suggest that this middle ground that we're talking about has significantly lower levels of utilization than people expect or want in their labs. And for you watching, that represents an area that you can have a huge impact for your organization by putting in procedures, policies, solutions in place that can improve that over time. One practical way to align everyone early is a SIPOC example exercise. So this is where you look at your current processes and find the real problems, and it only takes 30 to 60 minutes. This isn't about drawing a perfect process map. It's about capturing what actually happens on a day-to-day. So it's not about using idealized SOP language. It's what actually happens. What's interesting here is that you actually start in the middle of this. So you start with process and then work your way outwards. So in this example, the question about the process really is how does someone go from needing an experiment to completing it? So for example, with the HPLCs, this involved the scientists normally a week or two in advance planning their weeks. Maybe they know they've got samples coming in, so they look at the equipment calendars, make a block booking for 3 days, come in that first day, get their sample and reagent prepped, get the instrument set up, do the actual run. In their case, most of the time they ran them overnight. So the next day they'd come in, check the results, maybe quickly check the blanks and positive controls to make sure the experiment ran correctly, rinse the system, and then run it again if needed. Once you know the process, you expand outwards. So who supplies it? Is it lab ops teams, IT, vendors? What inputs are required? People need trained on the equipment. Is there approvals for booking, SOPs, samples, reagents? What outputs are produced? Is it results? Is it results that feed into data sets, field runs? And then you identify the real customers. So this isn't just the scientists. This is also, project teams, principal investigators, lab leadership. The value of SciPoc here is that it surfaces assumptions. We need this to identify the real problem, which we then need for a simple project charter. So this doesn't need to be a long document, but it does need to discuss and answer a few critical questions. I know what you're thinking, another spreadsheet, but we have seen people go wrong in the past when they don't have the right buy-in to actually make change happen. And lab ops is a very strategic role, as you know, and these types of documents really show that and document that. You want this to include what exactly are we trying to improve and why does it matter? Who owns this work day to day? Who needs to be involved for changes to stick? What's in scope and what isn't? What risks or dependencies do you already know about? And without this, what we see is utilization efforts tend to continue with half-hearted attempted fixes or solutions which don't stick. Maybe you're on the call here today and you've actually already tried something and it's not worked for you. Following this procedure correctly, might change that. So we've spent some time on the defining part of DMAIC, and doing that part right sets everything else up for success. In the measuring stage, that's where credibility is built. You you need that reliable data and a baseline to compare against later, so that you can really show that there's a business case here for change. The first step to gather data is to agree on definitions. What counts as book time? What counts as usable time? These definitions are crucial and might be very specific to your types of labs. This is also crucial for what you ultimately want to quantify, such as the amount of time an instrument is actually usable. So, for example, maybe it requires frequent routine maintenance, and that takes up a significant amount of time. So the actual usable time for that piece of equipment would be less. You might want to focus your efforts on certain machines or areas of concern that you already know about. So I doubt many of you are kept up at night worrying about benchtop centrifuges and how much they're being used. But your most recent high spend equipment in your lab, that might be another story and something that does cause you concern. It's also worth considering what peak versus off-peak looks like. Again, this varies by lab type and equipment type. Some labs are run 7 days, have shifts. Some are more 9 to 5, and the same can be said for different types of equipment in your labs. Then you establish a baseline, so not a perfect one, just one that everyone agrees is reasonable. So at this stage, you're looking at baseline utilization, cancellation and no-show rates, downtime and maintenance impact. Then you can start to stratify. So maybe look at differences by instrument, by team, by time of day. You'll also want to capture the voice of the customer here, but in a really structured way. So turning the scientist that's saying, I can never get time into something measurable, like the average delay for that scientist to actually do their experiment was 2 weeks. That's a really big step forward. Spending a bit more time here usually saves a lot of time later. You need that trusted baseline. But we know that getting this data can be really hard. And from what we've seen, this is because in practice, utilization data usually comes from a mix of imperfect sources. So when people come to us looking for a unified scheduling system, we see them often using a mix of these not fit for purpose systems. So maybe some use booking tools, room booking tools. These work well for rooms, but they don't work well for scientific workflows. What we actually see most, even in large enterprise accounts, is shared calendars and spreadsheets. These are often poorly adopted by the actual scientists in the lab, impossible to analyze, and actually just lead to more confusion than clarity. Most of the larger companies we speak with also have maintenance or asset management systems in place. These are strong on service history, but people come to us because they're weak on the day-to-day usage and don't engage the scientists who are actually doing the experiments. The issue isn't that these tools are bad, it's that they're often asked to answer questions and solve problems that they just weren't designed for. Something else worth mentioning here is power or IoT sensors. They can tell you when an equipment is on or off, but they rarely explain who's using it or why, and they're expensive to implement. One interesting insight we uncovered from a larger lab environment based in Boston is that when labs use a dedicated fit for purpose booking system, booking behavior tends to correlate closely with actual usage. This doesn't mean the booking data is perfect, but it does mean that behavior improves when the system supports it and when the system is actually designed for it. When people trust the booking system, they book more realistically. When bookings are more realistic, utilization data becomes much more meaningful. So we've defined what we want to do. We have data sources. Now we want to analyze that data. We also at this stage should have spoken to people and observed the problems. So at the analysis stage, it helps to look beyond utilization percentages and ask where capacity is being wasted. Tim Woods is a useful mnemonic for thinking through different types of waste. It might feel like all of these examples interrelate and interact, which is exactly the point. These don't need to fit your scenarios perfectly. Maybe there are logistical challenges around transport, inventory, motion, and waiting. Maybe there are procedural and cultural challenges related to overproduction, overprocessing, defects, or skills. These are all things that are common in the lab. For example, from my time in research, I had to walk 20 minutes with samples across the research site to access a really specific centrifuge that I needed for an experiment. This is a clear transporter motion issue, depending on how you want to classify it. Another example is going through radiation training every single year when I was a researcher, but I actually only used the X-ray machine, which the training was for, about 10 times in that 7 years. So I spent probably as much time training in that area as I did using the training, which is just not an effective use of people. These don't always show up clearly in a utilization number, but they might be areas of waste impacting your lab's efficiency and therefore your utilization. Another way to look at this, if you don't love the Tim Woods example, is to use a simple Ishikawa fishbone diagram. You put the problem on one side, for example, low effective utilization of the shared HPLC systems. Then you brainstorm possible causes around categories like people, processes, equipment, samples, facilities, and data. For example, with the HPLC, their facility lacked sufficient dedicated short-term storage. Their data was challenging to get off the instrument, and the process around equipment booking was chaotic and inefficient. So actually, it wasn't a lack of equipment when they dug into the issue. From there, you take the most likely branches and you dig deeper using something like the five whys. So you keep asking why until you reach something upstream and actionable. Very often, the root cause isn't a person or policy, it's a missing system, an unclear rule, or a workaround that became normal over time. This step allows you to identify and fix root causes, not symptoms. And ultimately, with utilization, stops you from buying lots of equipment that you actually might not need. When labs do this analysis, honestly, a few themes show up again and again. People hoard time because they're managing risk individually instead of collectively. Visibility across the instrument fleet is poor, so no one trusts the data. Monitoring tools get installed, but behavior doesn't actually change. CapEx decisions get made on incomplete information, and often no one has clear ownership of utilization as a system. These are real and pervasive problems that we see in R&D today, but they are solvable. So how can we make improvements? We have definitions, measurements, and data all showing a problem and a baseline to improve from. Now it's time to brainstorm possible fixes, then prioritize them based on impact, difficulty, and risk. So brainstorming might bring up different types of solutions. Some fixes might be procedural, like booking rules, approval thresholds, clearer ownership. Some are more technical, like better data access, integrations, or visibility. Some are operational, like changes to maintenance scheduling, training, behavior, or sample handling in the case with the HPLCs. You want to then map the solutions you come up with and brainstorm onto this diagram. So hopefully it's fairly obvious that these three solutions all complementary and all fall into the top left quadrant. They're easy and cheap to implement, and they have a large impact. For example, that group that we've been talking about with the HPLCs, they also toyed with another idea of automating their data pooling from the equipment into their LLM and doing automated QA/QC analysis to rapidly identify which runs would need to be rerun. So their thinking was that that would stop the booking behavior, and it would instantly give uh, the researchers and scientists results that they could then use to quickly decide if they needed a rerun. Ultimately, though, this was decided that it was too complex and costly to implement, and the other solutions that they came up with, because they were all top left quadrant, it made sense to implement them. And when they did that, they realized that actually the more complex solution just wasn't needed. Then once you've done that, you can assess what effect these will have on day-to-day operations, and sure they won't cause any other problems in and of themselves. Then you can pilot the solution. So maybe there's a small group or a lab that makes sense to start first, and you can, quantify the impact that that solution has. The important thing is that fixes should directly address the root causes that you identified earlier. One thing we see consistently at Calira is that utilization improvements have positive knock-on side effects. Visibility improves, which reduces friction. Downtime becomes more predictable. Booking conflicts decrease. CapEx planning becomes evidence-based rather than reactive. You now automatically track utilization and end up with fair, structured, AI-ready data. And you can action that data to ultimately improve utilization. So utilization is now no longer vague. It is a reliable data that you can manage. But don't just take my word for it. As Johannes showed earlier, we have data to show that this is more than possible. Organizations of various sizes and types in different continents doing different science have all observed and measured improvements. Utilization improves when teams have a reliable and effective scheduling system combined with structure, visibility, and credible data. You can see from these numbers that over a year of using Calira, these organizations all improved utilization across their instrument fleets. We aren't saying that this is all because of us. There's no single lever here that caused this improvement. It's the combination that works. So better digitization, better procedures, and an improved data-driven culture around equipment and utilization. The final step I want to talk about is control. So you've made an improvement, now you want to and keep it even when things get busy or people come and go from your organization or your organization's finances become better or worse. That's when you really want to have control in place so that you can actually maintain this over time. What you're seeing here is a control chart example. Earlier, when we defined what we wanted to improve and measure, we may have came up with some upper and lower control rates, and this might vary between, different equipment and different lab scenarios. For example, maybe for your flow cytometer, you decided that actually you wanted the utilization to be around 50% on any given working week. So if utilization falls below 40%, you want to take a closer look. That might be your lower control limit. However, if it goes above 60%, more than 1 week in a row, maybe you want to make sure that it's not becoming a bottleneck. Maybe you also want to explore daily trends. Maybe, previously with the flow cytometer, you discovered that Monday and Tuesday were actually quite quiet days, and the solutions you implemented were aimed to improve that. So that's what you want to track. Or maybe you're not tracking utilization. Maybe you're looking more at cancellation rates or failed runs or unexpected downtime. Whatever it is you determine to be important to your problems, that's what you want to track and have control limits for. And as I said, that might vary across your instrument fleet and across your different labs. This doesn't mean policing behavior, it means monitoring trends over time so that you can distinguish noise from real signals. What is important is that without this step, teams often slowly drift back to anecdotes and reactive decisions. So to recap, we've discussed the importance of utilization tracking and lab equipment scheduling as a whole. We've gone through a real world example with the HPLCs. Hopefully, you now have an intro into DMAIC and how it can be applied to lab equipment utilization. I really do hope this has provided some practical tips to tackle specific challenges in your specific labs and ways that you can define the problem, measure what's really happening, analyze root causes, improve it with targeted fixes, and ultimately then control it so the improvements stick. With that, I'll hand back to Johannes to wrap things up. And thanks for listening.
Thank you very much, Craig. I think this was great. A lot of information, obviously, but you'll all get this in a YouTube format afterwards. So we'll keep the next slide very brief. If you're working on utilization, most labs really only need three things. That is a consistent way to book the equipment or the pieces of equipment across the labs. Secondly, visibility into equipment, people, and maintenance. And thirdly, clean operational data that you and AI can actually use. So we, as Calira, we've designed a system that supports that from the equipment setup and booking through to maintenance tracking and the structured data that I've just been speaking about. The proof points that you see here on the slide show the scale and the types of organizations that are using Calira today. And the implementation is typically lightweight. Labs can move at their own pace. Adoption is driven through simple booking and mobile access, and integrations are available where needed. And of course, enterprise security and compliance basics are built in. Just looking at a case study, this example shows how better visibility supported better decisions for the company Lonza. They had a lot of capital tied up in equipment, but no ongoing reliable view of how intensively it was actually being used. And once they had the continuous utilization data, the conversation shifted. Instead of relying on that gut feel or manual tracking, they could objectively see whether existing capacity was being fully used before approving new spend. And that transparency fundamentally improved CapEx decisions, reducing unnecessary purchases, improving planning, and making sure that capital was directed where it was genuinely added value. Now, yes, I believe we're moving into questions now. If you'd like to go deeper, the QR codes here link to a utilization white paper and a detailed case study. Thank you very much. Over to you, Will.
Great, thank you. If you are watching this webinar right now live, if you just mouse over your screen, you see at the bottom there is a Q&A button. You can click that and make sure that you ask a question in the Q&A. We've already had one in, so we're going to move to that immediately. But if you have a question, do please type that into the box at the bottom there. So the first question that we sort of had through was from Francesca. It is, how do you decide on what the quote unquote right utilization level should be for any one instrument or a class of instrument?
Yeah, that's a great question and something we hear quite often. So I wish I could have like a really simple answer for you, but it will be specific to your situation. So what I would start with is the role of the instrument and the aim for it in the first place. So maybe was it purchased because it was mission critical and it was meant to be a really high throughput piece of equipment that should be used a lot? Is it specialized or an occasional use piece of equipment? So maybe it was purchased for like one specific project and you probably knew that it wouldn't be used a huge amount, but it had to be purchased because of that project. Or maybe it's something that your scientists do use on a regular basis, but you don't want it to become a bottleneck. So consider that first, what the actual aim was. Then maybe think about practical constraints, like how much maintenance does that piece of equipment need? Because that takes away from the usable time. Is there a large amount of setup time for that equipment? How hands-on is it? So can the experiment be set up and run while the scientist is doing other things, or do they actually have to be there? Um, that can really help with, again, deciding how much it can actually be used. You might also want to consider the investment that was made in the first place. So how much was the equipment and what is the ongoing cost of having it? So is there like maintenance contracts and expensive running costs associated with it? Because again, that might impact how much of a priority it is to focus on that piece of equipment. And then you want to use that to define kind of a reasonable target range and revisit that over time to see if you can, improve it with various solutions that you're putting in place.
Amazing. Thank you, Craig. One more question to go here. Just notice we've got a hand raised. If you do have a question, please actually put it in the Q&A panel at the bottom. The next question we had in from Russell, which is, how long do you actually need to go through the measure sort of stage before you can trust the baseline data? Like, how long is a typical amount of time? Like, it's probably not a day and it's probably not a year, right? So what would you
Yeah.
say, Craig, is something like the right amount of time there?
Yeah, again, that's a really interesting question. Um, so you want it to be long enough to capture kind of a normal cycle of work. So maybe for you that's, you know, a month or 6 weeks, or maybe a little bit longer if things do tend to fluctuate a lot and there's going to be some fluctuation. If seasonality matters, so like for January is a quiet month for you and February is really busy because people are ramped up. Obviously, account for that. If there's projects that come in waves, or you're about to have a hiring cycle, again, account for that. But you don't want to wait until your baseline is perfect because then you're gonna you've taken up so much time that could be spent on the solution. So account for those things, but don't kind of let it retract from you actually moving past the measurement stage. So maybe that's 6 weeks, maybe that's 12 weeks, to have a full kind of quarter. But it really does depend a little bit on your specific scenario. But just try and get a baseline that is at least reliable for you.
Totally. Right. So we had a question come in here. I'm going to click this and hopefully it should show up live for everyone. Apologies if this is a naive question, but in addition to utilization and booking, are you able to host information like servicing contracts, user manuals, asset location, booking maintenance, etc.? If so, do users find it valuable to help manage their spend in these areas?
Yeah, absolutely. On our platform, you can do all of that. You can also put in things like the purchase information of your assets to kind of track depreciation. But in my opinion, having all those things in one centralized place, whether it's our platform or somewhere else, is absolutely key. So that you can kind of track all that in a manageable way. You don't want to have this information stored in lots of different places because it'll make it so difficult for you to actually track that and improve it over time. So as much as you can bring everything into one place, you definitely should.
Good stuff. Right, the next question that's come in this time, another anonymous one. Great presentation. I have been using SharePoint list with fully customized UI that have built-in possibility for scheduling and visualization in the calendar view. There are some limitations with the number of rows, but apart from that, one can export data in Excel and easily analyze. How does your product make a difference? Can you further customize it? Thank you.
Yeah, that's a great question and really interesting scenario. And again, something that comes up all the time is people using kind of smart sheets or SharePoint to try and schedule their equipment and track their equipment. I would say that because our platform is custom built for lab equipment, it has a lot of functionality beyond just the calendar view. As we've already discussed, you can put all your equipment details and all the documents associated with the equipment as well, which is useful. Um, it seems like you're having to kind of manually do all that exporting of the data into Excel and then analyze it. With our platform, you can really easily export that via an API and build that into dashboards, which is really useful and means they update over time automatically. So you can actually see your utilization charts and see whatever information is kind of crucial for your decision making. So it'll take away a lot of the manual steps that you're currently doing. Um, Another thing I would mention is kind of just the ease of kind of adding equipment in as time goes on and adding and removing users and controlling access permissions. With, something like SharePoint, there's a lot of manual steps to do all of that. Whereas again, a kind of dedicated platform like ours, you can do that just much in a much more streamlined, straightforward way. You can create like access groups for equipment, control what people can book and when, and do that, with really simple click interface, not kind of a complicated SharePoint setup that it sounds like you currently have. But I'd be happy to discuss it with you to see if our platform would actually make a difference in your specific scenario.
You just have to tell us who you are because you're
Yeah.
anonymous, but that's not a problem. Um, good stuff. We have another question here from Roman. Is it also possible to link data to be used in ELN so people see in real time where to go with their samples if more than one equipment is present?
Yes, Roman, I love that question. I think people are more and more aware that they want to have their various systems. If they can't have everything in one system, they want their different systems to talk to each other to kind of streamline things from both the scientist perspective and the lab ops perspective. And yes, you can definitely do that with our platform. We already have kind of full-fledged integrations into some ELNs that make things really seamless for the scientists and people in lab ops. And we also have our API, as I've discussed, that can pull out the equipment data from our platform. So you can link that into your ELN so that your scientists can see, I've got my samples, I need an HPLC. They can then use our platform, and with that integration to the ELN to really seamlessly find an HPLC in that example that would have availability at the soonest possible time to really streamline their work. So hopefully that answers your question, and again, be happy to show you that on a call.
Amazing. I think we are running out of questions at this point. So I think without further ado, we're probably going to call. No, we do have one more actually, another anonymous one coming in. Building on the above, do you have integrations with the Dotmatics ELN?
So not currently in like a click it to be on integration, which we do have for some of the other ELN and LIMS systems. But as I said, we do have it in our API, so that's definitely something we could discuss with you. And really, really interesting question. I know that's came up before. I don't know if Johannes wants to add any other information about kind of how we work with partners on integrations, but really interesting question, and I would love to speak with you about your lab and how we could do that for you.
Yeah, absolutely. Happy to add some stuff. Um, so as Craig mentioned, we don't have the fully fledged integration like with Benchlink, for example, where you can right away book the equipment from the registry. But we also work with our partners on a case-by-case basis, right? So if you are interested in an integration to Dotmatics and would like to use both systems side by side, we're happy to work with you on that. So it's not that complex anymore as it used to be.
Great stuff. I think we are slowing down now in the number of questions coming in. So if you do have one, if you have your finger hovered over the enter button and you're ready to send it, now's your time. Don't be shy. I know whenever I attend a webinar, I am always a bit scared of running a question. Then afterwards, I'm like, oh, I wish I did. If you feel you have one, do please put that in now. Um, uh, we've had a thank you as a question. That's very nice. Thank you very much. Um, we we're all reachable over LinkedIn and uh, our email as well, which I put up here on the screen for you, Johannes at Calira.co and Craig at Calira.co as well. So if you have any further questions after this call, feel free to reach out to us directly. Other than that, thank you very much, everyone, for your time in coming along today. If you're watching this live or whether you're watching it on the recording, it's been a real pleasure to run this for you today. So thank you very, very much.
Thank you. Bye bye.